Hi there. Here's my solution to question 4.16. So we have a power model here where x is the diameter of a tree in centimeters, and we are taking the natural log of that, multiplying by this slope. We are adding this constant, and the output is the natural log of y being the above ground biomass, so the amount of the tree in kilograms that you can see above the ground. So we are told that this is a power model and we're supposed to convert this back into a form that looks more like a power model. So first of all, I want you to recognize that when you have the natural log of the explanatory variable compared to the natural log of the response variable in a linear form like this, that's what indicates a power model. Let's take a look at that. Here's a generic power model. The output equals a constant times the explanatory variable of the input to a power. Now notice what happens when we take the natural log of both sides. Over here on the right side, I can take that natural log and I can divide it into the natural log of a plus the natural log of x to the b, but I can put the b in front of the natural log of x. So notice the power model really does convert into a linear form. Here is the input, the natural log of x, times the slope. The slope is actually the power on the explanatory variable, plus the constant. The constant is the natural log of a, and the output is the natural log of the response variable. So if the natural log of x compared to the natural log of y, if that is linear in form, then I know that x and y follow a power model. And that's what's going on in this circumstance. So bottom line is, b is exactly the slope in this linear format, and the natural log of the a that I'm looking for, that's equal to the constant. So if I go back, right here, this 2.42, that is the power on x. So if I'm trying to find my equation, I know this already. So my explanatory variable is going to be raised to the power 2.42. So the only thing I have to do is find a, and that's found by using the constant here. I know that the constant is equal to the natural log of a. So don't forget then, a natural log is a log with a base of e, the argument being a, and that equals -2. So if I change the form here, this says that e to the power -2, that is equal to a. So I can approximate that in my calculator pretty quickly. So I'll hit the second button and the natural log button. That will give me the e to the power. I'll put in my power of -2, and that will give me, let's call it 0.14. There is my value for my constant a. So now I have my, call that the 0.14. Now I have my power model. I'm done. So my predicted biomass in kilograms is equal to 0.14 times the diameter in centimeters to the power 2.42. So that is the answer to part A right there. And then the only thing I'm left to do then in part B is to estimate the biomass of a tree with a 30 centimeter diameter. So without working too hard, I can make that prediction by simply substituting 30 in place of the x. So my prediction is 0.14 times 30 to the power 2.42. So we'll substitute that into the calculator, be done. So 0.14, and we're going to multiply that by 30 to the power 2.42. There we go. So we have about 525.73 kilograms, if you will. And there's our prediction. Very good. That's question 4.16.